The Webb looks so far out that it's capturing light that's been travelling for over 13 billion years. But the universe has been expanding, and so the light has been stretching. And so for the most distant galaxies, we're looking back in time almost to the Big Bang.
There is a star whose path to us defies the standard cosmic scale in a universe where distances are measured in the years it takes for light to travel rather than in kilometers. This star, Earendel, is extremely far away, and its light ended 12 billion years ago. In contrast, light from stars started its trip less than 1.4 billion years ago, when the Earth was formed. He traveled a great distance through time and space before arriving on Earth. In contrast, the distance between it and the Sun is merely 8 minutes of light. Since the dawn of life on Earth, Earendel's light has been traveling across space to reach us. Earendel appeared to be an unseen entity until the Hubble Space Telescope's eyes peered through the obscurity. The finest detective novel ever written. This star is more than simply a star. It's the farthest star we have ever seen, shattering previous records. Beginning only 1.4 billion years after the planet was created, the light of Earendel has traveled almost 12 billion years to reach us. So how do we go about detecting items that are far away? And what does this finding tell us? Astronomers have long endeavored to stretch the limits of the visible world in their quest to chart the cosmos. This region is defined not only by the speed of light, but also by the capability of our apparatus. Every star and galaxy on this cosmic horizon is a historical beacon, beckoning us to explore its past. The star Earendel is situated on this boundary's edge. Its light first appeared about 12 billion years ago, providing us with a unique window into a virtually uncharted period of Earth's past. As usual, the naming of this celestial body was fitting from the start, highlighting its uniqueness and significance. The star is known as Earendel, which translates to morning star in Anglo-Saxon. Earendel is a particularly fitting name since it represents the star's function as a messenger of the world's creation. The term cosmic dawn describes the period of the universe's history that occurred hundreds of millions of years after the Big Bang, when the first stars emerged. The world's dark era came to an end, stars and galaxies created, and light flooded the universe for the first time. The tool that first made Earendel known to us was the Hubble Space Telescope. Hubble's expansive view of the vastness of interstellar space depicts a far-off star. The first observation is not a reliable conclusion. We list data from astronomers, diverting light from gravitational lenses, and cosmic forces are all needed to identify the cosmic sound signal. Unlike most stars, Earendel does not seem to us as a flaming disk. It is referred to as light, yet the haze of space and time obscures its true nature. Even still, this fading picture has a wealth of knowledge and serves as the beginning of a scientific expedition that dates back to the dawn of humanity. In the annals of astronomy, only few instruments have altered our stars. See the Earth from the Hubble Space Telescope's perspective. Earendel's finding is a testament to astute observation. Hubble's sophisticated optics are being used by astronomers to study the cosmos and find brilliant light originating from all stars. It's like trying to find a needle in a haystack. The key component of Hubble's equipment is operated by Wide Field Camera 3. Since Earth's atmosphere often blocks ultraviolet radiation, its sensitivity to this wavelength makes it possible for it to detect the high-energy light from far-off stars. It's a challenging position. As they joined their original endeavor and continued their space marathon, Earendel's lights grew dimmer and redder. His finding ought to yield a combination of positive outcomes in addition to becoming a useful tool. Researchers are always attempting to explore the depths of the cosmos' immensity and solve the mysteries of the far-off universe. Earendel's finding is a significant step in this regard, as it has always been challenging to explore distant galaxies. Writers nowadays tend to focus solely on the brightest stars, quasars and blazars while observing faraway space. These phenomena serve as cosmic lighthouses, guiding light for millennia to come. We are, even at a distance. The brilliant light that is shielded from space travel reveals the lives of the few galaxies that have been discovered to yet. Nevertheless, it is fortunate that the star's location illuminates it and allows us to view it, presenting the gravitational lens, nature's own mirror lens. This phenomena happens when the gravitational pull of a massive object, such a galaxy cluster, warps the surrounding space, causing light from the object behind it to bend like light coming from a magnifying glass. Light is bent by glass to focus on the focal point. Earendel's finding is a classic gravitational lensing case. The Earendel galaxy is located behind the WHL 01378 galaxy cluster. The light from the galaxy bends and spreads, enabling it to traverse a much greater planet than our own. In the absence of this organic magnifier, the star's dim light may remain obscure and enigmatic. Beyond Earendel's discovery, gravitational lenses have far-reaching implications. It is now a vital instrument in the astronomer's toolbox, enabling us to study things that are beyond the reach of our most potent telescopes. By depicting the unseen material that produces the lensing effect, these lenses allow us to see the intricate structure of far-off galaxies, witness dramatic events like supernovae in the early cosmos, and even search for dark matter. We may also gauge the boundaries of our comprehension of the physical universe with the use of gravitational lenses. It offers a lab for examining how light and gravity behave, as well as proof that the interaction between them is as predicted. When examining far-off celestial objects, this phenomena is crucial. By enlarging the image to fill the field of vision, it not only makes the light stronger but also offers an alternative perspective of view. This can help us comprehend the nature of distant objects by revealing data about their motion and structure. Consequently, a vast window into the world has been made possible by the anomalies in the universe that Einstein's theory of general relativity anticipated. The secret to locating the star is this. We divulge the tale of the photon choice there, deep within Earendel's character. Similar to the Rosetta Stone, Hubble data translates these antiquated symbols into narratives about stars and cosmic occurrences. Scientists have found that Earendel is not just incredibly brilliant, far brighter than our Sun, but also very old, based on data gathered by the Hubble telescope. Its brightness suggests that it is a giant star consuming nuclear fuel at a quick pace and leading a fast and furious life. Earendel's spectrum looks like the fingerprints of elements found in the star's atmosphere, even by cosmic standards. The star's composition may be inferred from its spectral lines, which show that it is made of material from the early cosmos that is deficient in the heavy metals found in young stars like our Sun. One cannot emphasize how important Earendel's discovery is. As a star during the universe's beginning, it provides us with a unique window into the moment when the first galaxies and stars appeared and eventually vanished into the empty, black space that was our early planet. This period is known as the dawn of the universe. There was a lot of change in the globe throughout this building phase. The first stars served as the building bricks for the first heavy elements, which in turn served as the building blocks for planets and life. A significant advancement has occurred with the handoff of the cosmic exploration baton from the esteemed Hubble to the James Webb Advanced Space Telescope. It provides us with a closer look at Earendel, the farthest star ever seen, by opening a window into early space. When Earendel was initially seen by the Hubble Space Telescope, its true nature was unknown. Is it a dense cluster, a star, or something else entirely? The misunderstanding was dispelled by the James Webb Space Telescope's confirmation that Earendel is an object, most likely a star with a brilliant star at its core. Using spectral analysis, the James Webb Space Telescope was able to map the star's actual color. With a temperature between 13,000 and 16,000 Kelvin and a brightness almost 1 million times that of the Sun, it is a B-type blue giant star. This huge star demonstrates the superiority of stellar evolution and is comparable to Aldebaran and Regulus in the Milky Way. Events by James Webb have expanded beyond of the Earendel system, as evidenced by the physical star rising of Dorcas. This galaxy, which gets its name from its form, is said to be the biggest galaxy ever found at the beginning of time. Large galaxy clusters can become mirror lenses because of a phenomena called gravitational lensing, which can refract the sun's arc light 1,000 times. James Webb was able to view Earendel and the brilliant star that the early galaxy generated because of this intervention. Based on these findings, a potent region of space has been identified where star clusters with ages under 5 million years are actively producing new stars. Work on these clusters by the James Webb Space Telescope may one day provide an answer to the riddle of how Earth's clusters arise. Astronomers have been baffled by it for decades. Earendel is not a mystery. Rather, it is a luminous, old planet that holds the key to comprehending the immense cosmos of its era. When combined with surrounding items, it forms a jigsaw that, when assembled, may disclose events on the early planet, when creation and evolution were paramount. There is a wealth of knowledge in the vicinity of Earendel. These objects emit light that is the characteristic of a young cosmos, with wavelengths stretched by space's expansion. Astronomers will be able to ascertain the elements' composition and the circumstances leading up to their formation by examining this light in order to ascertain the chemistry of the early cosmos. Earendel's closeness is particularly interesting because it is thought to be the location of the first galaxy's formation. These galaxy stars might belong to a hypothesized first generation of stars, known as a triple population, which originated from the primordial gas that filled the cosmos immediately after the Big Bang. One of the great mysteries of contemporary astronomy is the finding of the Trinidad star. In the early cosmos, these stars were enormous, hot, and had a brief lifespan. They were made entirely of hydrogen and helium. Their presence is crucial to comprehending both the development of stars and the reionization phase, which is the transition from an opaque to a light transparent environment. Finding our star is comparable to unearthing a fossil. Despite its challenges, it offers concrete proof of the early stages of the history of star evolution. A finding of this kind would support the early universe idea and offer hitherto unheard of insight into the origin of the first complex atoms. Earendel is a lighthouse that points us in the direction of unidentified star groupings, even if it is not our star. The Earth's existence within the Milky Way suggests that we are stargazing, and the traces of these primordial stars will be obscured in the information we record. Earendel and her pupils have evolved into something far more than components of light in their quest to discover the mysteries of the first world. They are similar to bread in that they transport us back to the first brilliant star's commencement, when it shone brightly and created the cosmos.